Hello everyone. In this video we will take an exercise to be able to apply what we have learned about the input and the output in MATLAB, in addition of course to what we have learned previously about arithmetic. So let's read the statement of the problem. It says, write a MATLAB script that calculates the roots of a second order polynomial. The polynomial has the format f of x equals ax squared plus bx plus c. The script has to prompt the user to enter the coefficients a, b, and c. And then we are asking you to format the output using the disp command. There is another question is asking, is it really a good idea to use fprintf? So what I would recommend is that you pause the video here for a couple of minutes and you try this exercise on your own, and then you can compare your solution to what we will be presenting. All right, so let's start with a basic discussion of second order polynomials. Geometrically, when you sketch them, they represent a parabola, and there are in fact three different possibilities for how these second order polynomials can look like in terms of their roots. They could intersect the x-axis in 2 points, and in that case there are two different real roots. The other possibility is that they barely touch the x-axis in 1 point, and in that case there is two repeated real roots. And the last possibility is that this second order polynomial or parabola doesn't touch the x-axis at all. So this is all these cases, this is the x-axis and this is the y-axis. And as such, in the last case, we have two complex roots. All right, but then there is a famous equation that was derived, and it allows you to calculate the roots of a second order polynomial regardless of which case. So you don't really need to pay attention to which case you are in. The equation can take care of this for you. And that, if you remember, it says that x equal negative b plus or minus square root b squared minus 4ac divided by, the whole thing is divided by 2a. So with the plus sign, you get a root, and with the negative sign, you get another root. All right, so let's get, so that's sort of a basic analysis of the problem. Let's get to coding. We will start with a new script here. We should give it some representative name. So for example, I'm calling this roots second m. So let's save this. All right. It's usually good to start with some documentation of what's happening here. So this script calculates the roots of a second order poly given user input of a comma b comma c, and the poly is ax squared plus bx plus c. All right, so let's actually start by getting the input from the user using the input command as we have learned. I would say that a equals input, and then I can give a message to the user, please enter a. Let me put a semicolon here to avoid rewriting it to the screen. I can copy this whole thing and paste it here twice because I also want to get B, and I message I will put B, and similarly here I want to get C. I will ask the user to enter C here. So this way I'm getting user input. So this is basically user input. Then we should calculate the roots. Obviously, in mathematics, if you have two options like plus or minus, you can put these signs in this way and life is good. But in programming, you have to calculate the plus case separately and the negative case separately. So I can define root number one. So let me call it this way, root 1 equals, and there will be also root 2 equals. So only difference in sign. So root 1 will be negative b plus sqrt times, of b squared and then minus 4 times a times c. So that's basically the first root. I can actually do this on two steps. So in the first step, I will calculate the numerator, as you see here. And in the second step, I can take the previous numerator and divide it by 2 times a. Please, let's not make the mistake 2 times a in this way, because this way and according to the hierarchy of arithmetic, the a will go to the numerator. So it has to be 2 times a between parentheses, as we see here. All right, so that's the first root. I can pretty much copy everything here, and that will be the second root. I have to be careful, so I need to update this to R2, yeah, and update this to R2. Also, this has to be updated to R2. So root 2, root 2, root 2. And also, instead of positive, I need to put a negative sign here, and that will give me the second root. So I can actually call this block roots calculations. So I'm done with calculating the two roots. Now displaying the results. I will be using the disp command as recommended in the question. So let's do disp. So in the disp, as we learned, we have an array of strings, especially if we are trying to display a message. So for example, I can say first root is, and then maybe I should leave space here. And then the first root is root 1. But as we said before, root 1 is a number. I need to convert it into a string to be compatible with an array of strings that appears in the disp command. So there will be num to str of root 1. I can exactly do the same thing with the second root. Let's say first, I can do exactly the same thing with the second root. So I can copy this to save some time and put it here. So it will be disp instead here of first. This has to be second. And then num to str root 2. So let's actually do some testing. Don't ever develop a code and release it for usage before you do some testing. So let's actually do some testing with some of the cases for which we know a solution. So for example, let's come up with some cases here for which we know a solution. So suppose I take x squared minus 1. In fact, we knew the solution here because this can be factorized into x minus 1, x plus 1. So we know the solution are 1 and negative 1. So let's actually do this testing here. I'm going to run enter a. So a is 1, b is 0, c is negative 1. And yes, we get the first root is 1 and the second root is negative 1. Let's do another test case for which we know the solution. X squared plus 1 equals 0. So again, that will give you x minus I times x plus I equals 0. And that means that the roots are I and negative I. So let's actually do the testing here. Maybe TLC first. Clear. We can run. A is 1, B is 0, and C is 1. And yes, we got two complexes. So 0 plus 1i and 0 minus negative I. Of course, we can keep doing more testing as you wish, but at this stage, we have at least some confidence. I would recommend, of course, to do more testing. For example, a case where you have two equal roots. For example, let's do this here, like x minus 1 square equals 0, which is basically x squared minus 2x plus 1 equals 0. And we know there are two repeated roots which are 1 and 1. So let's actually test this case really quick here. Run A is 1, B is negative 2, and C is 1. And yes, the answer is correct. I want actually to go back to the question statement. There was one comment or a little question at the end that says, can you use fprintf here? And in fact, no, it's not recommended, especially if you will be dealing with complex roots or roots that contain an imaginary part in general, because unfortunately fprintf does not write the imaginary part of a number. So in summary, we had an exercise that allowed us to practice basic input and output in MATLAB. It also allowed us to practice some arithmetic precedence or hierarchy ideas, and eventually it allowed us to calculate something useful. I have to say that MATLAB has a built-in utility to calculate roots of polynomials, but at this stage, while we are at an early stage of learning programming, it's not recommended to use these built-in functions. Later on, of course, they are recommended because, they are optimized, fast, written by experts. But at an early stage of learning programming, it is better to try to practice based on the key principal concepts that we developed step by step. Thank you so much, and see you in another video.